The magnitude of the resultant force is approximately 15.26 units.
DeepSeek just released two new models, which are now available on OpenRouter. On OpenRouter, we have DeepSeek version 3.2 Special and also DeepSeek version 3.2. The two models are designed for high computational efficiency. This video will show you how to use any of the models via OpenRouter to build an AI math and physics agent in Python that can help people in solving math and physics problems. To work with the agent in Python, we'll use the open source framework Vision Agents to build a voice AI application. Vision Agents is an open source video AI framework for building voice and video applications in Python. It has a plugin for OpenRouter. So using the OpenRouter plugin for Vision Agents, you can access multiple LLMs to build AI applications. The plugin serves as a gateway for using multiple LLMs, so you can swap one LLM with another. To run the demo in this video, you will need API keys from Stream and Stream API secret. You will need an API key from 11 Labs, OpenRouter, and DeepGram. So this is how the demo works. To speak to the agent, we will use 11 Labs as the speech-to-text component. Then we use one of the DeepSeek v3.2 models from OpenRouter as the LLM. To hear from the agent, we will use another model from 11 Labs, which will serve as the text-to-speech component. To start, you will need to have a Python project and install Vision Agents along with its plugins. In the context of this project, you will need the following plugins. The OpenRouter plugin will help you easily swap one LLM with another. After installing Vision Agents and the required plugins, you can now go ahead and open your code editor and start configuring the voice agent. In my Python script, I will add the following imports: OpenRouter for hosting the DeepSeek models, GetStream to provide audio and video transport, 11 Labs for both text-to-speech and speech-to-text, and Smart10 for 10 detection. Next, I will define an async main function and initialize the model we want to use. These are the two new models from DeepSeek, so you can use any of these models. Vision Agents also allow you to define personality for the model. Since we are creating math and physics assistant, we want the model to talk like math and physics tutor. Next, I will go ahead and create a new agent using Vision Agents agent class by defining all the following parameters. We have the edge network to provide low latency audio and video transport so that we can chat with the voice agent in real time. We give the agent identity and detailed instructions, as well as its personality. Next, we add the model we want to use in the agent's definition. So here we pass the LLM parameter and access the DeepSeek model from OpenRouter. Next, we add both the text-to-speech and speech-to-text components and the 10 detection model. To be able to have real-time conversations with the voice agent, we need to use the edge infrastructure to create a stream video call so that when we run the Python script, we will be able to launch a web UI to interact with the voice agent in real time. So let's add this code snippet. First, we create a new video call and also join the call and keep it running until the user ends the call. The last thing to do is to launch the agent. So in summary, we first install Vision Agents and its required plugins and add all the following imports. Then we define an async function and initialize the model we want to use. In this example, we are using one of the newly released models from DeepSeek. We create a new agent using Vision Agents agent class by specifying all the following parameters. Then, to interact with the voice agent, we need to create a new call and also join the call and keep it running until the user ends the call. I'll bring the terminal and run the script.
The magnitude of the resultant force is approximately 15.26 units.
How did you get that?
I used the law of cosines. First, I found the angle between the two vectors. 180 degrees minus 25 degrees equals 155 degrees. Then I plugged the values into the formula. The magnitude of the resultant force squared equals 8 squared plus 13 squared minus 2 times 8 times 13 times the cosine of 155